Okay, so I think I got cut off with 11.1, so I'm going to do 11.1 part 2, continued. I was talking about bounded and monotonic sequences, so let me repeat that just in case you didn't get that. Bounded and monotonic sequences. So if a sequence AN is bounded and monotonic, then it converges. Basically, if a sequence is bounded above and increasing, so if it's bounded above plus increasing, then it converges. If it's bounded below and decreasing, then it also converges. Okay. If you look at AN, which is 1 over N, is bounded and monotonic, that means it converges. You can see 1 over N, it's 1 over 1, 1 over 2, 1 over 3, so it's monotonic decreasing. It's bounded below because 1 over N is greater or equal to 1 if you want, right? Greater or equal to 0. So it's bounded below and increasing, so it is convergent. Now we know that every convergent sequence is bounded. So if you know it's convergent, it's bounded. But not every bounded sequence, not every bounded sequence is convergent. So if you know it's bounded, it's not enough to be convergent. It has to be bounded and monotonic, bounded above and increasing, or bounded below and decreasing. For example, AN equals -1 to the N. This is bounded but not monotonic, so it's not convergent. It's bounded but not convergent. Same with sin N. Sin N is bounded but not convergent. Okay. So here's a few examples from your text. 30, page 736. AN is 4n squared minus 3n over 2n plus 1. It says determine whether the sequence converges or diverges. If it converges, find the limit. Remember what I said when we did the epsilon delta definition? We find the limit if the limit the function is convergent. If the limit does not exist, the sequence converges. If the limit does not exist, the sequence diverges. So let's find the limit of 4n squared minus 3n plus 1. This is the limit as n goes to infinity. When n is infinity, only the leading power counts because it's like dividing everything by n squared. So it's the limit as n goes to infinity of 2n, which goes to infinity, so it diverges. Okay, so that sequence diverges. Number 40, AN equals e to the 2n over n plus 2. Again, let's find the limit as n goes to infinity of e to the 2n over n plus 2, which equals e to the limit as n goes to infinity 2n over n plus 2. 2n over n is 2, so it's e squared, which it converges. Okay. 54. So basically, we go back to limits again. AN equals n to the 1 over n. Infinity and n to the 0, we can't tell. We gotta do logs. Okay, so ln an equals 1 over n ln of n. The limit as n goes to infinity of ln of an equals limit as n goes to infinity ln of n being the variable here. So you get infinity over infinity, so we do L'Hopital's rule. Derivative of ln of n is 1 over n or 1. Limit as n goes to infinity, this goes to 0. So ln of an goes to 0. That means, so we do e to get goes to e to the 0, so an goes to 1. So it converges to 1. Okay, it converges to 1. All right. Now 72, page 736. Let's look at 72. If you deposit $100 at the end of every month into an account that pays 3% interest per year compounded monthly, the amount of interest accumulated after a month is given by. So the amount of interest accumulated after 1 month, 0.0025n minus 1, or 0.0025 minus n. It says find the first 6 terms of the sequence. So they want I1, I2, I3, I4, I5, I6 by plugging in n equal 1 and equal 2. What I'm going to do, I'm going to have you do it on the calculator just to save the hassle. So we're going to key in the equation. Let's go to sequence. So mode, let's change the function into sequence. So go to function and make it sequence. You can see when we do that and hit Y, so u of n instead of a of n, it's okay. So it's 100, and then 1, oh, that's going to be in parentheses, so we need parentheses. 1.0025 to the power n, and then minus 1 divided by 0.0025, and then minus n. Okay, so the n minimum is 1, u of n minimum, u of 1, we don't have u of 1. Okay, so we're gonna go to table and find these. So we want to do, hold on, go to table set and set it up with 1, and change in table is 1. Table, oh, it's not doing it. Table start, okay, second table. 1, u of 1 is 0, u of 2 is 0.25, u of 3 is 0.75, u of 4 is 1.5, u of 5 is 2.5, and u of 5.1 and u of 6 is 3.76. So we got all these terms. Let me write them down. So 0, $1.50, no, 0.25, sorry, 0.25, 0.75, 75 cents, 150, 2.51. Those are the interests for every month. Okay. Part B. How much interest will you have earned after 2 years? So 2 years is 24 months. So I-24, you can do that. Second table, just key in 24. And it will be $70.28. Okay, and you can look at 82, and I'm done with 11.1. So that's the second part of 11.